He returned to his dissection to see what happened next. He was amazed to find that the eggs had hatched, releasing thousands of rod-like parasites into the mosquito. He watched as the parasites migrated through the wall of the mosquito's gut into its body. They seemed to know exactly where they were going. They wriggled their way through the body up into the head, then one by one into the salivary glands. They were ready to be injected when the mosquito next fed.
It seems, looking back, so obvious. We're so familiar now with the transmission of many diseases, including malaria, by mosquito bites. But that was a really, really major scientific breakthrough, to know that the mosquito could inject the parasite into the human bloodstream through that biting process.
Ross had uncovered the key role of the mosquito in what is one of the most intricate life cycles in biology. If an Anopheles mosquito feeds on someone infected with malaria parasites, it takes them into its own body. When the infected mosquito feeds again, it injects the parasites into another human being. The parasite is a protozoa. Inside the human body, it mutates and destroys red blood cells. This causes the disease we know as malaria. The life cycle is an elaborate chain. Break one link and the parasite cannot spread.
When Ross made this discovery, for which he was eventually awarded the Nobel Prize, it provided the possibility of actually beginning to prevent this disease which had ravaged humanity for thousands of years. This was really one of the first examples of where an understanding of the life cycle, meaning how a disease is transmitted, could actually be applied to preventing that disease. Now that it was known that mosquitoes transmitted malaria, one could then attack the mosquitoes, and in fact, Ross set out after that discovery to cure the world of malaria.
He sees this breakthrough as now the answer to the prevention of malaria. It's really very simple. If mosquitoes transmit malaria, what better than to kill the mosquitoes? That is his message to the world, to the malarial countries of the world: kill the mosquitoes.
An extraordinary battle against nature began. They started with the mosquitoes' breeding grounds. The larvae lived underwater, so marshes were drained. Slow-moving rivers were cleared, and oil was spread on the surface to suffocate them. Then they brought in the bombs.
Watch. Here it goes. This well-engineered blasting is a thunderclap of doom for millions upon millions of unborn mosquitoes.
There were some notable successes. In the 1930s, Mussolini was able to declare the area around Rome malaria-free for the first time in history. But keeping marshes drained was a constant battle. What was really needed was something that would get rid of mosquitoes once and for all. One group of people came up with the answer.
In every military campaign that our forces, meaning U.S. forces, have been involved in, when we were engaged in military campaigns where malaria was transmitted, we have always had more casualties to malaria than to hostile fire.
In any tropical theatre of war, you, as an army, always lose more soldiers to malaria than bullets. So it makes sense for an army to be interested in malaria and ways of protecting its soldiers.
The American military had long devoted huge resources to disease research. During the Second World War, they made malaria their top priority. They began to test thousands of compounds to see if they could come up with a uniquely powerful insecticide. They came up with a legend. It destroyed the nervous system of mosquitoes so completely that minute quantities were deadly. Sprayed onto surfaces, it was still killing mosquitoes a year later. And it was cheap. Even the poorest country in the world would be able to afford it. Its name was DDT.
This success was then taken as a justification to start a worldwide eradication program of malaria, whereby the entire world actually would be sprayed with an insecticide to get rid of the mosquitoes and subsequently get rid of the malaria.
In the optimism of the post-war years, the new World Health Organization came up with a bold plan to eradicate malaria completely. Most of the staff and money of WHO were devoted to the task, and they said malaria would be gone by the 1990s. DDT was to consign it to the history books. The strategy was simple: to break the life cycle of the disease on a global scale by wiping out mosquitoes. It was a huge undertaking. No corner of the world was ignored. No home too humble to receive attention.
They were able to completely remove the disease from Europe, North America and Russia. The incidence of the disease fell dramatically in many parts of the tropics as well.
Success spurred them on. It was the mosquito's darkest hour. No hiding place was secure.
There were also breeding places in potholes high up in the mountains. Local mountaineers were enlisted to deal with them.
This was a fantastic development, and it gave them hope that they could actually eradicate the disease completely from the world.
It was dramatically reduced in South America. It was dramatically reduced in India and Sri Lanka, where there had been in India 80 million cases prior to eradication, and they were able to reduce it down to 50,000 cases.
Everything seemed to be going to plan.
Our children will be the first generation freed from the enslaving fever.
Malaria was being described as a disease of the past. But then the mosquito fought back.
Mosquitoes are remarkable, resilient insects. One female can produce up to 1,000 offspring in a lifetime. And in a very few weeks, you can have millions of offspring from that one individual mosquito female. If one of these offspring happens to be resistant against an insecticide, you can imagine that being so highly fertile, within a very short period you can get the development of totally resistant insect populations.